Now let's look at interest rates in the big picture, and specifically I'm talking about the yield curve and the term structure of interest rates. The term structure is simply the relationship between interest rates and yields. So how does that interest rate, or the relationship between interest rates and yields, interest rates and maturities. So how do interest rates change as the time to maturity on securities gets longer? So does the interest rate go up, does it go down, or does it stay the same? So what you see here are three different yield curves for Treasury securities at different times. So in 1980, where interest rates were falling, 2000 where it was relatively flat, and 2013 where it's upward sloping. And so in 1980 we call that a downward sloping yield curve, or an inverted yield curve. 2000 is flat, as I mentioned, and the 2013 is upward sloping or normal. And the reasons for that are what we need to talk about now. Before we get into detail on the reasons, let's talk about how we actually construct that yield curve. First, we have to find the average expected inflation rate for the time period that we want to chart. And so here's an example. Let's assume inflation is expected to be 5% next year, 6% the following year, and 8% thereafter. So we have to earn these inflation premiums to break even versus inflation. So our inflation premium in year one is going to be the 5%. In the 10-year inflation premium is going to be 5% plus 6% plus 8% that we're going to get 10 times divided by 10, because remember we're calculating an average. So on a 20-year premium, it's 5 plus 6 plus 18 times 8 divided by 20. So that's how we get the inflation premium that's going to go into the yield curve. Then we need the maturity risk premium. Now this is not a formula that you need to memorize. You'd always be given a formula that we think is appropriate for calculating the maturity risk premium at any given time. So it would be some percentage times t minus 1, and that would give you the maturity risk premium at time t. So for example, a 1-year maturity risk premium, well, remember that's kind of a trick question, that's going to be 0 because we said that the maturity risk premium only applies to long-term securities regardless of the issuer. So a 10-year MRP, using that formula that we gave a moment ago, is 0.1% times 10 minus 1. So 0.1% times 9, and then for the 20-year, 0.1% times 19. So now we can add those to R star, which remember was that real rate. And so let's assume that R star is 3%. So now we can get a 1-year, a 10-year, and a 20-year rate. And so we're taking R star of 3% plus our inflation premium plus our maturity risk premium, and those are the premiums that we just calculated. So that gives us a 1-year, 10-year, and 20-year rate as given. So now just hypothetically, let's move away from that specific example and just hypothetically consider the yield curve. Just as we saw, the real risk-free rate tends to be flat, so 2%, 3%, somewhere in that range. And then on top of that, we have an inflation premium that tends to grow over time because we generally think that prices are going to increase over time due to inflation, a general rise in prices. And then the maturity risk premium is going to rise over time. If we have a formula like what we saw a moment ago, it's a linear formula, which means that the greater T is, the greater that risk premium is. And that makes sense to us because what the risk premium does is it compensates me for having to wait to get my my principal back on basically this loan that I'm making on a debt security. So an upward sloping yield curve means is due to an increase in expected inflation and that increasing maturity risk premium. So how do then Treasury yield curves relate to corporate issues? Well, corporate yield curves are going to be higher than Treasuries, but not necessarily parallel. Well, the question is, why are they higher? Well, they're higher because of those two premia that we talked about in that chart early on that do not relate to Treasuries. And those two premia are the default risk premium and the liquidity premium. And so those two together make up the spread between corporate and Treasury securities or corporate and Treasury yield curves. And so that spread is going to widen as the corporate bond rating decreases, meaning the default risk premium is going to get higher as the quality of the bonds deteriorates. So that means our corporate bond yield spread is just DRP plus LP. Those are those two risks that are only related to corporate securities, corporate debt securities. So here's just some representative interest rates as of February 2013. U.S. Treasury rate was 0.83%, and AAA corporate bonds, so those are the highest quality corporates, were at 0.93%. So again, these are very low interest rates. AA 1.29 and single A 1.67. So you see the interest rates rising, and then you see the spread rising as the quality of those corporate bonds falls. So now if we plot yield curves for treasuries and corporate securities of different credit rating on the same graph, you see what we were talking about a moment ago, that the corporate securities are going to plot higher, but not necessarily parallel. And so this is showing us over different maturities from these different issuers. So now let's kind of briefly talk about why the yield curve looks the way that it does. And so one theory is pure expectations. And so what that's saying is that the yield curve tends to be upward sloping because of investors' expectations of future interest rates. So investors expect interest rates to rise, so long-term rates are going to be higher than short-term rates. So this theory assumes that the maturity risk premium for treasuries is 0, and that long-term rates are an average of current and future short-term rates. So if this theory holds, then you can use the yield curve to figure out future interest rates. And so that's what we're doing here. These are current interest rates, so a 1-year, 2-year, 3-year, 4-year, and 5-year rate at the yields shown. So if pure expectations holds and we can back out or back into future rates, then we can figure out what the expected 1-year rate is 1 year from now, or the 3-year rate 2 years from now. So here's how we would do that. So we call these forward rates. So if you look at this timeline, what we're calculating here is a 1-year rate 1 year from now, because we're calculating that X. And from that list of rates or yields on the previous slide, we know that the current 1-year rate is 6% and the 2-year rate is 6.2%. And so that means that I could invest for 2 years at 6.2%, or for 1 year at 6%, and then turn around and make another 1-year investment. And I need to figure out at what rate. And so the way I'll do that is I'll take 1 plus my 2-year rate squared, because I'm going to get that for 2 years, and set that equal to 1 plus my 1-year rate times 1 plus that unknown rate, and solve for the unknown. So the end result is that my 1-year rate 1 year from now is 6.4%. So now I could do the same thing for a 3-year rate 2 years from now, because I know the current 5-year rate is 6.5%, the current 2-year rate is 6.2%, so I could say 1 plus that 5-year rate raised to the 5th power, because I'm going to get that for 5 years, is equal to 1 plus the 2-year rate squared times 1 plus that unknown 3-year rate raised to the 3rd power. And I solve for x. So now if I do the math, I find that x, the 3-year rate 2 years from now, is 6.7%. So our conclusions are that if the MRP is not equal to 0, then this doesn't work. But most evidence tends to support this view, so this is a reasonable way of estimating future interest rates. Some macroeconomic factors that influence interest rate levels. We won't spend too much time on this, but things like Federal Reserve policy, deficits and surpluses, international issues, the level of business activity. So basically general economic issues that are not controlled by the firm have an impact on interest rate levels.